Hey everyone, thank you for joining us for our next session, Automating GitHub Repo Maintenance with AI Agents. My name's Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today.
Hello, everyone. Welcome to the live stream today about automating GitHub repo maintenance with AI agents. I see we've got people coming from all over. So we've got Argentina, Uruguay, Pakistan, England, Canada, Anna from Washington, San Diego. So it's great to have people tuning in from all over. If you haven't shared yet, share in the chat where you're from and, maybe what you're interested in learning today in this topic. So what are we going to talk about today is how I deal with my two problems, right? So problem number one is that I've got too many issues in my GitHub repos. And problem number two is I've got too many GitHub repos. So I've been trying to relieve my burden by using AI agents. And sometimes that means using GitHub Copilot agent mode. Sometimes it means actually programming an agent using an agent framework like LangChain or LangGraph or Pedantic AI. And there's just a range of solutions. So I'm going to walk you through my solutions. I'm going to try to live demo all of them to get you a feel for how they actually work. And hopefully this will give you some ideas for how you can maintain your own code repositories with the help of these agents. So let's talk about problem number one, too many issues. This is a good problem to have. When you have too many issues in a repo, it means that it's a popular repo. It means people are using it. So it's a good thing. It's a good thing. I'm glad we have so many issues. It means people are using it. People are letting us know, what's going wrong. So the biggest repo this is happening on is the Azure Search OpenAI demo repo. If you've heard me talk before, you've probably heard about this repo, or maybe you've deployed it yourself. But it is a very popular repo. It's, it's got 5,000 forks. It's been deployed thousands of times, and currently it's got 510 open issues, and quite a few of these issues are old issues. Like we can actually see I do have Stalebot enabled on this repo just marking issues as stale when they've been inactive for a period of time. So you can see that like 56 of them are even marked as stale. So there's quite a few issues. Quite a few of them haven't any activity in a long time. So in theory, we should be able to close a lot of these issues, right? Because I don't actually think there's 500 things wrong with the repo, at least not 500 things that I can fix. So how can I more efficiently close these issues so that we can have a cleaner issue tracker and so that my manager is happier? So when I'm deciding whether to close an issue, this is the thought process I go through, right? Like, I can definitely close an issue if we fix the bug, right? Either with a code change, or maybe it's just a documentation change, or maybe the bug was in some part of code that's been deleted since then, right? So it's just an obsolete bug. I can maybe close an issue if it got marked as stale, right? So if the Stalebot marked it as stale, that means it hasn't had activity in a certain amount of time. Sometimes it means an issue can be closed, but not all the time, because sometimes an issue hasn't had activity for a while just because there's nothing more to say, but it's still a valid request. So that's why I don't have the Stalebot automatically close issues, because personally, I hate when I file an issue on a repo and then Stalebot marks as a stale and then comes in and then closes it, even though it's still a valid issue, right? So I don't want to just immediately mark something as closed just because it hasn't had activity for a while. That's just one signal that maybe it can be closed, but we don't know for sure unless we really look at it and see, like, is this still a valid open issue, right? If it's some issue that it was very environment specific, we've never replicated, like, well, there's not much we can do about it. And then some things are feature requests that are just too far outside the scope of a repo. That's hard to like reason about what's really outside the scope of a repo, because in theory, we can do anything, but we have to have boundaries in life, maybe. So, sometimes we might decide to close and say something's out of scope. And there's some issues that we can't close because there's still active bugs, or there's still valid feature requests that are in the scope of the repo. So it's important to think through how a human would close an issue in order to figure out how we could use an AI agent to close the issue, because we want to replicate that same decision-making process with the AI agent, right? So what does the human need to know to make a decision about an issue? We need to know, what does the code currently look like? How does the code work? What are the features in it? What are the bugs? We need to know what the documentation describes, whether something's in the documentation. It's helpful to look at the pull request to see if any pull requests specifically fixed an issue. It's also helpful to look at other issues to see if an issue is actually a duplicate. It's been discussed before. There's already a resolution in those other issues. So sometimes that information lives inside my head, but if it's not in my head, then I can, look in the actual repo, look on GitHub, and get all the information that I need in order to close an issue. So now that we've thought through how a human would triage issues, how could we automate issue triaging with AI agents? So I'm going to show you 3 different approaches that range from a low-code approach to a very high-code approach that all have their pros and cons, right? So we'll start with the low-code using VS Code plus GitHub Copilot plus GitHub MCP, and then we'll go from there. Now, the important thing is, for all of these approaches, I am trying to keep a human in the loop, meaning that I don't want to just have an agent go off and close issues on its own without checking with me, because I do not yet trust agents to that extent, right? I want to always see what the agent has decided and then say, yes, okay, good, close it, or no, I disagree, keep it open, right? So that, I think, is a really important thing when we are working with agents these days, is to keep a human in the loop. Agents can get us a lot of the way there, but not 100% of the way. And we want a way of supervising and confirming whether we agree with an agent behavior. Okay, so let's start with GitHub Copilot. All right, so what I'm going to do is, actually, I've got the repo open here. So this is actually, the Azure Search OpenAI demo. This is the RAG repo. This is the one that has all of the open issues. So I have it open in VS Code. So what I can do in here is that I've got a custom prompt. And the way I did this was, if you go to your command palette, let me try and make this bigger. You can say new prompt file, and then you can name your prompt, and then you can define your prompt there, right? So like, find an issue to close, do not actually close it. So this is making a custom prompt file is a helpful thing to do if there's some sort of thing that you want to do repeatedly, right? Some sort of process you do repeatedly. You don't want to have to keep copying and pasting the prompt, from some notepad. Instead, you can store the prompt in your repo and then reference that prompt from the agent mode here. So I already have it. So I'm going to close this one because I've already got my prompt in here. Let me just delete that one. So here is my issue triager prompt. So this says that it works in agent mode, and it says, okay, you're an issue triager. Do not close them unless I tell you to do so. This is how I keep the human in the loop. And I tell it, like, okay, first you're going to find stale issues. You're going to examine the issue. You're going to search the docs. You're going to decide if it's obsolete. And then you're going to output this information. And then I've got a bunch of other tips here based off of my experience using it. So now the way I use it is, I'm just going to say /, and then I I can just select this prompt from the slash menu. So when you do slash in agent mode in GitHub Copilot, it will show you all the possible prompts. So these could be prompts in your repo. These can be prompts from MCP extensions, from built-in tools, from VS Code extensions, tons of different prompts. So I'm going to say find one issue to close from Azure Search OpenAI demo. All right. So it knows that it needs to follow the instructions here and find an issue to close. Now we need to check to see, do I have GitHub MCP server enabled? I do. So this is really important. I've got the GitHub MCP server enabled. This server can do all kinds of things. It's got like hundreds of tools. So it can search code, it can search issues, it can do all kinds of things. So this prompt assumes that it has this GitHub MCP server, and that's what it's going to use to find issues, right? So you can see that first it lists the issues. So it does this query to the MCP server. And then it starts searching through the repo. And this is actually pretty fast for it to do because it's using just the built-in search of VS Code, which is quite fast. So it found an issue and it said, okay, all right, here's a summary of the issue. Here's the suggested closing reply. And then I can say like whether I want to make any changes or not. Now, so what I would typically do is I read through the suggested reply, and I, often check the issue too to make sure I have full context. And I can go back and forth and say, oh, let's like change the reply. So let me actually show you one that I did earlier. Just because, I want to, as I said, I like to actually like, give my own input. So I want to show you one I looked at earlier. So you can see, what I did here when I had more time to actually look through the reply. So here it has suggested closing replies for a different issue. And I said, I didn't think that the reply was quite thorough enough. So I said, oh, okay, mention this additional fact as well. So then it said, okay, here's the new suggested closing reply. And I said, okay, good. That looks good. Please close the issue with that reply. And then it used the GitHub MCP server to add that comment to the issue on my behalf and then closed the issue, right? So it used two different tools in order to add the comment and then close the issue. So let me show you what the actual issue looked like yesterday that it closed, right? So you can see that it added the comment on my behalf because it's the GitHub MCP server is authenticated as me. So when it adds these comments, it's happening to me, and that's particularly why I want to be in the loop, because if it's coming from me, like I'm associating my name with these comments, so I want to feel good about them, and yeah, so it did all that work for me. So I see a question. Is there a global prompt directory you can pull from if you want them modular across repos? Yeah, that's a good question. I believe so. When you do new prompt file. Yeah. So what you're going to do is when you say new prompt file, instead of doing .github/prompts, which is in your repo, you're going to say user data folder. So you can see on the Mac, it's going to the library. So that's a global folder. So yeah, if you are using the same prompt, and this would actually be a good prompt to go across multiple repos as long as it didn't have the repo hard coded in it. Then you could store it in your user data folder, and then you could always reference it there. Great question. Okay, so that's the technique of using a prompt. So this works pretty well, actually. The tricky thing here is that we had to make sure we had the MCP server enabled. If I hadn't had the MCP server enabled, it would have been a lot harder for it to actually do anything. It wouldn't have been able to search the issues and post the comments and all that stuff. Approach number one. Okay. Now, and the other drawback, so one, I had to have the GitHub MCP server enabled. Two is that it could have used any tools from that MCP server. And I generally don't like to just have powerful tools enabled all the time, right? Because in order to use that prompt, I had to have that server enabled, and I had all these tools enabled. And this is a lot of tools, and it makes me uncomfortable to have all of these MCP server tools enabled all the time. So I'd rather have more control over exactly what tools this process is going to use. So what I'm going to use next is a custom chat mode. And this is slightly different from a prompt, right? So for a custom chat mode, similarly, you could do, let's see, custom mode. Yeah, so you would do new mode file, right? And so once again, a custom chat mode can be in your repo. In this case, it goes in .github/chat modes, or it could be in your user data folder, right? And so for the, the question about where this is stored, this is a global folder that would be referenced in all of my windows, right? So if I stick it in my user data folder, I will have this chat mode available for all of my VS Code Insider windows. So in this case, I would put it in here, and I do already have it in here. I have it checked into the repo because I use it a lot. And so this one has a bit more information at the top. So we've got a description. We have a preferred model. I really like GPT-5. It's my favorite. I tried out Claude 4.5 today, and it is not my favorite. But everybody has their own preferences. So you don't have to say the model. But, since I've tested this with GPT-5 and I know it works well in there, I put the model as GPT-5. And then what I really like is that we can specify the tools, and you can configure the tools. So we can see here that I've told it that it can use a bunch of different tools. So this is a combination of built-in tools that it's allowed to use. And I actually restricted it quite a bit because in this mode, it shouldn't actually be doing much stuff to the repo itself, right? It looks like I did let it edit files, but I actually don't even think it would need to do that, right? Like the main thing it needs for the repo in this mode is tools to search the repo, right? So that's the most important things to enable. And then I enabled ones from the GitHub server, right? So here I've got add issue comment, assign Copilot to issue. That could be good. Get commit, get discussion, right? Lots of gets. See, these are all gets. So I'm very comfortable with giving it access to these read-only operations where it's fetching data and listing data. But I don't give it access to most of the write operations, right? The only write operation that it gets is update issue. So you can see the full list here. And it's still quite a long list. So it's got a lot of capabilities, and really you could probably get rid of quite a few of them. I don't know if it needs security advisors and secret scanning alerts, but they're pretty safe because they're read-only, right? And then we've got a really similar description here. So the big difference is really the tool configuration, right? But that to me is pretty important. I like that difference. So to use a custom mode, you go to your mode picker here, and you can see the built-in ones right now are agent, ask, and edit. Then we see our custom modes. So I've got a fixer mode, and then I've got the triager mode. So that's the one I want here. And I'll just say find one stale issue from Azure Search OpenAI demo to potentially close. I don't have to be this verbose. I could just say find an issue, and it would find it. Yeah, I see some commentary about favorite models. Everyone has their favorite models. I think 4.5 is a great coding model. I just don't like that it says absolutely and perfect all the time. That's it. I don't like being complimented, and I like that GPT-5 does not compliment me. That's why I use it. Okay, so here you can see this looks really similar, right? Like it's using the GitHub MCP server, and we are using the to-dos feature, which is it's a nice feature that you can enable in your modes if you want the model to come up with a to-do list and mark it off as it's going through its task. And then it's doing lots of searching here. So it's going to end up being a pretty similar experience. And here we go. We've got the candidate stale issue. This one's actually different from the other one. And we've got a suggested closing reply. right? And and it says a lot of things. Okay, so that looks pretty reasonable. Once again, I will go back to a previous one just so I can spend more time looking at that one. So here's the one I did yesterday. And so it said, it gave a reply. Once again, I told it to modify that reply. So you can see I very often will work back and forth with the agent. And it says, okay, here's the new suggested closing reply. And I said, all right, looks good. Close the issue. And it closes the issue and it marks all its to-dos as done. So there we go. Really similar to using the prompt, but the difference is the control of the tools. All right. So that works really well, actually. Like it's a pretty good way of going through issues and having it, as I'm saying, like the advantage of using an agent here is that the agent can really quickly do searches, look at other issues, and digest all that information. It can read faster than we can, right? Like the thing about agents is they can read a lot of context much faster than we can. And I consider myself a pretty fast reader, right? So they're really good at reading, getting all the information, synthesizing it, and suggesting something. And I like that it gives me a suggested reply, because I personally have a hard time like closing issues just from a social anxiety perspective. Like I feel bad closing issues, like I feel guilty closing issues. But if I have a suggested reply that is, well thought out and helpful, then I'm more likely to be able to close an issue, right? It gives me the ability to overcome my anxiety and guilt in order to actually post the issue. I see there's a question: at what level of simplicity am I comfortable going hands off for the agent? I'm only comfortable with that for things that are like really like low risk. So for example, I do have an agent that monitors my LinkedIn requests, right? So this doesn't have to do with any repos, right? So I have an agent that decides whether to accept LinkedIn invitations. And this is like really, really low risk, because the worst that happens is that I forget, like that I don't connect with somebody on LinkedIn, or I connect with somebody that I, maybe didn't want to connect with. But that's really not a big deal, right? It's just a social media acceptance. So for example, I'll just run the agent here so you can see it. And that's the only kind of thing I'm like really comfortable with having to be hands off. And even this one, the agent looks at it and I gave it the ability to say that it can't decide. So even in this case, I wanted the agent to have the ability to say, sorry, I can't decide on this one. It's not clear enough. So that then in that case, I just manually triage whatever's left. But a lot of times it is comfortable deciding, right? So you can see my hands are like, I'm not touching the screen. It's using Playwright in order to automatically go through those invitations and accept them. And it's using an LLM. Oh, look, and somebody's in the stream right now. Hi, Stephen. Then it's using the LLM in order to look at them and see like, oh, is this person technical? If they're technical, then it accepts them. If it's a recruiter, then it doesn't accept them. That's the criteria. And the LLM's very good at deciding that. So this is a kind of thing where I'm comfortable being fairly hands-off while still giving it an escape hook if it really can't decide, right? And so really, really low risk. And with a GitHub repo, like that affects other people, right? This only affects me, but if I close an issue, that affects other people and potentially means that their issue is not going to get addressed. So there, I need a higher level of confidence and a higher level of oversight. Okay, this will keep accepting in the background, so I'll close it. Yeah, that's a great question. All right. So the chat mode works pretty well. The disadvantage there is that you can. I'm very much in the loop, so I couldn't just like, how would I go and do this for a bunch of issues, right? Because these requests are all linear, they're all synchronous, right? Like I have to go and type in and say this is, do another one, do another one, do another one, right? What if I wanted to bulk process like dozens of issues at the same time? So in that case, I need a way of firing off a bunch of things at once and having a bit more control. So that's when I started writing similar workflows in Python programs. So in these Python programs, the idea here is that I'm going to write an agent that is going to find an issue, hand it off to the agent to use the GitHub MCP server, and then come up with a proposed action. So let me first show you like the simplest version of this over here. Okay. All right. So this is a Python program using LangChain v1, and you can see it is programmed using the GitHub MCP server. In this case, I'm passing in a personal access token, and this token only has permissions to a single repo. So that's a nice thing you can do. Like another way of really restricting the amount of damage an MCP server can do is that you can configure an MCP server, like the GitHub MCP server. I configured it with tokens that have very specific fine-grained controls, right? So like this token only has access to this particular repo and can only do certain things in those repos. So you can have a huge amount of control with these fine-grained tokens, and in order to reduce the amount of potential destructive action that an MCP server can take. And then I do another thing. I get the tools and I actually filter down the tools in code as well. So in this case, I really filtered it down and said, hey, these are the only 4 tools you are allowed to use, right? So I'm being very restrictive, trying to rein it down. And then I say, okay, find an open issue that can be closed. And it's using a really similar prompt. So we're going to see this prompt quite a bit. It's got some differences because now it has to use the GitHub MCP server for searching the code. So I gave it a bunch of tips for how to do that because it's kind of hard to do it well. But otherwise, it is a very similar prompt. So let me go ahead and run this one. Let's see if we can get it to find an issue for us. And in this case, this one is only going to come up with a proposal. It's not going to actually follow through on the proposal because we have to get a bit fancier in order to follow through. So this is basically an intermediary step before we get to my final solution. Okay, so here you can see the first thing it's going to do is find an issue. So it found some issues, and now it's starting to search the code. And this is one of the disadvantages of using the agent is that every time it needs to search the code, it does have to do a network request, right, to the MCP server, versus in VS Code where it could just search locally, which is faster. All right, so here we got a issue proposal. This is one we saw in VS Code as well. So they both found the same issue. It says we should close it, and here's the suggested reply message, right? So now I still need to actually do the reply. So this only gets us partway here, but I wanted to show you this code before we go to the more sophisticated code here. Let me just check on the questions here. Does the agent have a certain level of judgment when choosing to adhere to instruction? Is it rigid in the rule following? That's really going to depend on which model you're using. I do tend to use GPT-5 these days when I can. Let me see if that's what I'm using here. Don't steal that token. Here, this is using GPT-4 mini. I think because I didn't have enough quota for GPT-5. I need to get more quota for GPT-5. That's why. But generally, I prefer GPT-5 for instruction following and for not doing too much work, right? But it's still hard. Like in this prompt here, you can see I have a bunch of things that say you have a budget of 6 tool calls. I've got it like 3 different times in here. Do not make more than 6 tool calls. Because the problem was it was doing way too many tool calls, and I didn't have the quota for it. And I was even going over GitHub quotas because GitHub Search API itself has quotas, and so I was trying to keep it under. But I had to put this all over the prompt, right? So it's like all LLMs, right? They roughly follow the instructions, but there's definitely variance, and sometimes you got to do some prompt engineering. Okay, and then I also saw there's a question about if you want to see the LinkedIn agent, you can. I'll just put that in the chat. We'll share that in the chat so you can check it out. Everything I'm showing is is public code. So we'll share all the code we'll share in the chat and in the description of the video. All right. So this is the start of an agent that uses the GitHub MCP server, but we need to bring the human in the loop, right? So how are we going to bring a human in the loop? I could do like a command line interface where I could go back and forth and I have to like re-implement chat. Instead, what I decided to do is use this thing called agent inbox. So what's going to happen is that the agent is going to come up with a proposal. It's going to send it to agent inbox, which is an inbox of actions from agents for you to approve. And then I'll approve it in agent inbox and then decide, whether it's good. So here's the flow, right? So I find the stale issue using the GitHub API. Then I research the issue using a LangChain agent. Then I propose an action using a LLM. And then I send it to agent inbox. And I, the human, look at what's in my agent inbox and decide whether it's good or bad, or if I want to edit it. And then it goes back to the code and the code will close the issue. So let's see what that actually looks like. Let me go. So this is in another repo. Oops. This is a little fancier. Stop looking at my env. All right, I'll clear out. I'll reset all my keys after this. Okay, so here I've got my more sophisticated agent running in here. This is a LangGraph agent. So let me show you what it looks like in the LangGraph Studio, right? So my LangGraph agent goes through different phases. So let me go ahead and start off a new thread for this LangGraph agent. So it's already selected an issue and now it's researching the issue. And I can look at the traces here. And I can watch this. So this is using LangSmith, which is an observability platform. And it's a nice way of looking at the traces. So I can see like this call, going out to GPT-5 mini. That's what I'm using in this case, right? And then I can see all the tools it's using, right? So it's searching the code. It's fetching the file. It's searching the code. It's fetching a file, right? It's searching issues. So it's just doing all these tool requests and adding all this information to the thread in order to do a really, really thorough search, right? So this context window is actually getting quite big. You can see the number of tokens here. It says it's currently at like 18,000. Now it's at like 24,000 tokens. So the context window isn't getting quite big because it's doing all these tool calls and appending it all to the context. We could reduce that size by doing kind of summarization along the way. I haven't done that yet because it seems to work well enough. But it does get a bit long. So we can see all the different calls here to search code and fetch files and search issues and fetch files. And I do actually have a middleware that limits the number of tool calls because sometimes it just does too many tool calls. So I have a max tool calls of 8 right now. And after 8, I actually say, okay, now it's time. Now you're done. You've done too many tool calls. I'm cutting you off. You need to start summarizing it. Because if you let an agent, like if you give an agent access to lots of tools, like it can go hard, right? Like it can go forever. It just keeps on calling more tools and, increasing that context size. And at a certain point, it's time to finish up and make a decision, right? So let's see. Okay, so it finally did all those tool calls and then proposed an action. So once it proposes an action, that goes to my agent inbox. And so you can see actually I've run this twice and it found the same issue both times. And so it sent requests to my agent inbox to say, hey, this is action from an agent that needs your approval, right? So I can look at this and say, okay, All right, so this is the issue, and the agent wants to close the issue. This is the rationale for why it wants to close it. It wants to add a label. It wants to remove a label. Doesn't want to assign a copilot, and it wants to post a comment, and here's the comment. And what I really like about Agent Inbox is that I can edit all of this right here. So if I don't like the comment, I can go in here and edit it, right? So let me see if I can quickly, let's see, and then there are established fixes. Let me just add in 313 in there, right? Some will, okay, if you're still, I'm gonna get rid of that. Okay, so I can look at all this, see if I agree with everything, edit it, and that looks good. So what I'm gonna do now is say submit. So that goes back to the agent, and the agent then applies the decision and finalizes it. So now we should actually be able to see that decision, see it actually on the issue. So let me open up the issue. And here you can see the comment, and you can see it's closed, right? So this is the way that I have a human in the loop, right? Like I can kick off this agent wherever. I could kick off lots of these agents. Once they got to the point where a decision was made, those get sent to the agent inbox. I can look at the agent inbox, say, hey, what still needs action? I can see what it is proposing. I can edit it and submit it, and then it would go through to the issue. So I really like this way of this kind of user interface for having a human in the loop, because you've imagined eventually you could have multiple agents that are doing things that, some of them might need your approval, and you could just look at your agent inbox and say like, oh, okay, what actions need approval today? All right, so that is this approach with the agent inbox, and it uses some LangChain code to do this. Once again, let me share the repo for that one in the chat so you can check it out. Let me also share the one from earlier. So the simpler one is in this Agent Frameworks Demos repo, and then also the chat mode was in this Azure Search OpenAI demo. So everything I've shown is all open source, and you can check it out yourself. All right. Okay. So that was problem number 1, triaging issues. Just going to pause to see if there are any questions on that before I move on to problem number 2. Let's see. All right. Looking good, looking good. We can also tackle questions at the end if you think of any. So now let's talk about the next problem, is too many repos. So this is a list of all the repos inside the Azure samples org where I am the primary maintainer. That is quite a few repos. And the reason for all those repos is that there's so many different ways that you can build things in Python. And, some Python developers, use different frameworks, right? Like for web apps, you could use Django, Flask, Fast API, Quart. And for AI agents, you could use LangChain, you could use Pydantic AI, you could use semantic kernel, right? There's so many different ways that you can build. And I'm trying to show people that it's possible to build all of those things. And that leads to lots of combinations and permutations. And then I end up making repos for all these different combinations and permutations. So that means a lot of repositories. And that is only the repositories under Azure Samples org. I also have 365 repositories under my personal GitHub account. So quite a few repos. And these repos need constant maintenance, right? The Python packages and the NPM packages always need upgrading. There's like security vulnerabilities. We got to upgrade the packages. I do have Dependabot enabled in all the repos, and Dependabot in theory tries to upgrade your packages, but a lot of times it's not smart enough to figure out exactly how to do the right upgrade step, right? It doesn't do pip compile correctly. It doesn't understand UV, that sort of thing. So dependency updates is a huge pain point for me. And then sometimes you actually have to change the code when a dependency changes too, right? Like it actually requires code changes, test changes, all of that. APIs change, frameworks can't change. We have new tools, right? So we're generally moving from pip to UV, from black to rough, right? And we might want to make that change across all the repos. We have new best practices all the time. So there's lots of ways in which these repos need to be maintained, lots of updates that need to be made to them. And the interesting thing is that many of the repos need really similar upgrades, right? Like, I want to move them all to using, UV, right? And that's a very similar upgrade across all of them, but I can't just go and like edit the exact same file across every repo. Instead, there's like slight differences in every repo, right? So I need something that has the flexibility of making these similar upgrades. And it can't just be, a regular expression, right? It'd be great. Like I thought originally I was going to use like regular expressions to solve this, and I wasn't really looking forward to that. But the thing is, we need more flexibility than that because there's a lot of similarities in these repos, a lot of similarity in the maintenance that needs to be done, but they're not all exactly the same. So how do I maintain these repos as a human? Well, if I have a change that I think is a good change, I try out that change in one repository. Generally, I try the change in the repository that has the highest test coverage, right? Because some of my repos have very good test coverage, like 100% coverage and different kinds of tests. And other of my repos do not. So I generally test out a change in one that has the highest test coverage. And then if it's good, then I'll manually make that change across every single repository. And then I get bored and give up and decide there has to be a better way, right? So that's where we're going to bring in agents. So now GitHub has an agent that you can assign to issues in your repo. That's basically a background agent, an asynchronous agent that will work on an issue, inside of like a containerized environment on your repo to try and solve the issue. And that can be a really helpful way to make these really menial fixes so that you don't have to like check out the repo yourself. You can just say like, hey, Copilot, I need you to make this upgrade. Here are the steps to do it. Go and make this change and verify it, right? And then Copilot will send a PR and then you can verify the PR, right? So here's one I did last week. Let me open that up and show you, right? So here, I said, okay, you need to change this YAML file and, find it, update a version number, add this constraint and remove a section, right? And then I assigned it to Copilot. So here I assigned to Copilot. And then Copilot put its eyes on it. And then Copilot made a PR. And it does it within like 20 minutes or so, depending on how long it takes to work on it. And so then we can go and look at the PR and, I go and review it and I say, okay, yeah, that looks good. It bumped the version, it bumped that, and it removed that section. So it's a pretty simple change, but it's still more complex than just a regular expression, right? Because it did have to bump some numbers here. And so it's helpful to have an actual LLM on this versus, just my attempt at regexing. And you can see, it writes it up and you can go back and forth on it. So I did actually tell it to go back and forth on something, mostly just to make sure it could, so I can show you that it can reply, right? But you can go back and forth. If you find that it's gone like completely far afield, like its PR is really not what you wanted and you have to do a lot of back and forth, I would actually suggest that you close the PR, you close the original issue, and you make a brand new issue, right? Generally, it is easier once you realize that you didn't give enough instructions in your original issue. It's easier to create a new issue that has enough instructions and reassign that to Copilot than to go back and forth with Copilot on the original, right? Especially if you're going to go and apply the same issue to other repos, because you want to figure out what issue description is really going to, work the best so that ideally you don't have to iterate, right? The best is if it can get it in the right immediately, in its first shot. So I'll review it, I'll iterate, and then I will merge it. So when you do get the PRs, one tricky thing about the PRs is that humans, as a human has to approve the workflows to run. So that I find actually fairly annoying, and I filed an issue about it because I want it to automatically run the workflows so that it can see if they failed and address the issues. So a human has to approve the workflows to run. So if you have any CI, and then a human also has to mark it as ready for review. Hopefully that'll change in the future so that there's less buttons that we have to click. But it's saying if the PR is poor, I think it's best to write a new issue. Also, another thing you might want to do is improve the agents.md in your repo. That's a file that you put at the root of your repo that tells agents how to work with your repo. And generally, you want to have that if you're going to be using GitHub Coding Copilot Agent. It's going to be much more successful, right? So let's see. So I can show you for this repo, right? Here's the agents.md, the instructions for coding agents. Here's the overall code layout. Here's how you do, add new things, how add new settings. Here's how you upgrade dependencies. Here's how you check Python stuff. So it's just the most important stuff for an agent that it needs to know, and generally will make it background agents and also VS Code agents much more successful at working on a repo. All right, so that's how you can get Copilot to address your issues. But remember, I have lots and lots of repos, right? So how do I make it so that I can file the same issue across many repos, right? So potentially I have got like 500 repos that could need a fix, right? 500 repos, I'm actively maintaining perhaps, right? So how do I file the issues only in the repos that need that fix? So of course, I wrote a program and the program knows how to go through all my repos, look to see which repos need a particular fix, and then assign an issue in that case, right? And that way I basically automate the creation of issues across all the repos that need it. So I use a YAML file in order to say like, oh, okay, you're looking for any repo that has azure.yaml and it has this pattern in the file. And if so, you're going to make an issue with this title. And here's the issue description. And then I run that, run a check across all of my repos, and then it'll just make issues in each of the repos that are, met that requirement. And then Copilot, it auto assigns them to Copilot, and then Copilot works on it. Okay, so let me actually demo that so you can see what it looks like. So I was working on a new issue that I want to assign to a bunch of repos today. So here's the issue. I was just talking about the importance of agents.md. So most of my repos do not yet have agents.md. So what I want to do is assign Copilot to write an agents.md for all the repos that don't have it. And so I've got this, this is my test issue, right? This is the one I manually wrote and manually assigned. And it's got a description of what I want in it based off of what has worked for me well in other ones. And I assigned it to Copilot, right? So then I can go and see, okay, here's what it came up with. And I gave it some feedback here. And it looked at my feedback and actually, did it look at my feedback? All right, I'm going to go ahead and tell it to address my feedback. Okay, address my feedback. Okay, here we go. And then here you can see that I have to approve the workflows to run and mark it as ready for review. So now it's running, and also Copilot is going to address my feedback. So this is one issue. Now I want to automate this across all my issues. So what I'm going to do is go to my next repo that knows how to assign issues. This is my repo maintainer agent repo. And I'm going to say, okay, make a new code check. Let me make this bigger. That searches for repos that do not have an agents.md at the root. If the file is missing, then make a new issue based off this issue. And then I'm going to tell it to look at this issue, right? So I'm telling it to make a new automated code check based off my test issue. And that way it's going to write the YAML for me. I generally don't like writing YAML myself. So if I can have, if I can have Copilot write the YAML for me, that's great. So it is going to go ahead and figure out how to write this YAML. So it's going to look at that test issue, the one that I like, the one that seems to work fairly well. And now it's going to create the new YAML. So we'll see a new YAML pop up here soon. Okay. All right. So here's the new YAML that it wrote. So it said, all right, it's looking to see if agents.md is missing. If so, it's going to add this issue. And here's the issue description and assign it to the Copilot agent. Okay. So that looks good. It's even running the test to make sure the tests look good. Okay. I'm going to keep that. All right. Tests look good. Okay. And summarizing. All right. Looks good. All right. Now I'm going to tell it run a dry run. So then what I do is I do a dry run with the check just to see what issues it would make. So it's going to run a dry run. Oh, I see a question. Is it possible to assign things to a different AI, like assign to Claude Code? That's a good question. I haven't tried assigning. If you can assign it to Claude Code from your GitHub user interface, then you should be able to assign it in the API. I'll show you the code that actually does it. Assign. All right. So you just need to figure out what the assignee ID is, right? So if there is an assignee ID, then you would just use that assignee ID instead. So I've never tried assigning to another bot, but if it is possible in the GitHub UI, then it should be possible in the API, right? Because I'm just doing an API call that says, hey, assign the issue to this user. You could also assign it to non-robots as well. But, in the future, we'll have a mix of robots and humans, maybe mostly robots. Shouldn't call them robots. They're really agents. Okay, so this is running, and we can see that it said in the dry run, it would create quite a few issues. And that makes sense because most of my repos do not have agents.md yet. And now I can run it in non-dry run mode. So we can actually watch it make the issues. So how many is it going to make? It's going to make 33 issues. So here's the thing is that once you start automating this issue assignment to Copilot agent, you're going to end up doing more code reviews. Now, you can assign your code reviews to the coding agent as well and have it check its own work. But you should always be, reviewing code yourself as well. So there is an increased burden now of code reviews, right? Like I'm doing, spending more time on the code reviews, but that's why I like to have a good test issue to make sure that I like the result, the result that it makes. And before I go forward with creating the issue across many, many repos, right? So you can see it's making lots of issues. I'll just open up a random one, right? And you can see it made the issue and assigned it to Copilot, right? So it's going to make 33 issues like that across my repos. And pretty soon my inbox is going to be filled with requests from Copilot to review all these new agents.md files. All right. So that is that approach. And, the point is there, we've got these background agents and you can think about ways that you can offload some of the more trivial work, the more verifiable work, right? Especially the best thing is if you've got really thorough CI on your repos, like unit tests, integration tests, all that stuff, the better your CI, the more you can delegate to coding agents, right? If you do not have tests on your repo, it is very hard to delegate to coding agents because you have no idea if they've done it right. But if you've got really thorough CI checking everything, like the linting, the formatting, the actual functionality, then you can delegate more and more and more because you have the confidence that things are working, right? So my hope is that people are motivated in order to spend more time on the on adding verification so that they can delegate more to agents. All right, here's some parting thoughts here. I hope that you've got some ideas now about how you can start to, maintain code using AI agents. There's a range of ways you can do it. And I showed some of them, some actual Python programs, but really you can do so much using, GitHub Copilot MCP servers, and it can get you so far of the way. And in some ways it's better there because you don't have to maintain the code, right? You're just maintaining a prompt. And you've got that chat interface where you can like iterate, go back and forth. So I would say, start off with that more low code approach and only start writing programs if, you've got something that you're going to use quite a lot, like with a large degree of repetition. Or if you just feel like it, right? Part of why I write Python programs is because it's fun and I want to see what it's like if I actually, turn something into a program. I like programming, even if the agents do a lot of it for me now. Yeah, I do think that you can use the GitHub Copilot and more low code tools with great success, and you don't necessarily have to jump to writing full Python programs. And the great thing is that even if your approach doesn't work, you will learn more along the way about what works well, what doesn't work well, and what approaches you might be able to use in the future. And of course, if you find something that does work, do share them out with the world. Share your prompts, share your modes. If you do have a cool mode, we do have this repo, the awesome Copilot repo, where we have lots of prompts and modes that people share. That's a nice place to share modes as well. So yeah, do share things out and so that other people can learn. And this is a plug. We do have a series coming up. If you want to learn more about using Python with generative AI, we've got a whole 9-part series coming up in October, starting next week. And we're going to be covering a ton of topics. I'll be doing it in English. My colleague Gwen will be doing it in Spanish. So if any of these interest you, please do sign up for the series because it should be a really fun series. And we're going to be covering so many topics. All right, so now I can go ahead and tackle the questions. I did see some more questions come in. So Paulo asked, can you define what model the coding agent uses? Yeah, that's a good question. I don't think we have that flexibility yet. So I know, I don't know if you saw, okay, so I'll tell you what I do know is that the CLI defaults to, so we just dropped the CLI, which I think uses kind of the same, maybe the same agent or logic as the coding agent. And that one defaults to Claude, but there is an environment variable that you could override to set it to GPT-5. I don't think you can set it to any arbitrary model, but I believe at least GPT-5 is supported and maybe some other ones as well. So the question is, can we do the same with the background agent, the coding agent? The hard thing is actually that everything is kind of called the same. So here we go. Okay, about the coding agent. This is where we would see auto model selection. Let's see. The model is determined. Okay, so it says you cannot change the model used by the Copilot coding agent. It is Claude Sonnet 4. All right, so I guess they want a high degree of control of it right now. I imagine they would have more flexibility in the future, but currently you cannot change it, and it is Claude Sonnet 4. Good question. All right, let's see. Okay, questions. All right. Headless mode call. Okay, Angel saying about headless mode. Maybe you're referring to Playwright, where I'm doing. When you say headless, that might be a reference to Playwright. In this case, I am doing a head full call. Let me open this up. Head. Okay. Headless. All right. So I did headless equals false. Right. So this was an automation with Playwright. Playwright, you don't have to watch the browser. You can set it to either headless true or headless false. So in theory, I could actually run this in any sort of environment. You don't have to actually watch the browser pop up. I just think it's fun. But you can run it entirely headless as well. That's my guess as to what you were talking about when you said headless mode. But if you meant something else, let me know. Mario says, how to avoid over-engineering. Yeah, that's a good question. I definitely suffer from over-engineering. So, that's why I'm, even after I showed you all those things, I do encourage, I feel like the best, like for issue triaging, right? Like here, I think that the chat mode is probably actually a pretty good middle solution here where, I've got the control of the tools, but I don't have this full Python program. So this way, the nice thing about this is that it's easy for other people to modify and to use that are in the repo. If I've got other maintainers, and they don't have to worry about getting the Python program running, right? Because if I'm using this with other maintainers, then really I should deploy that Python program to Azure, add on a layer of auth, deploy the agent inbox, add on a layer of auth, maybe add on a virtual network, right? Like that's like getting really fancy, right? So the interesting thing is there's quite a lot we can do with custom chat modes. And there's a lot you can do also with just running these agents locally, right? If you're the only one that needs the automation, you don't have to go through all this effort of deploying things to the cloud, right? You can just be running these things locally. So I've resisted actually deploying any things to the cloud, which has made it much easier to maintain them. So I would say like, try out the simpler things first and see if you're really running against a wall. Because also now that there's a GitHub Copilot CLI, I think it's going to hopefully support chat modes at some point. And so then maybe we'd be able to just queue off a bunch of requests too. And I don't know, we'll see. So it's good to start simple. Any comment about the new agent CLI with Claude Code and Codex? I actually haven't used Claude Code. I'm not really a big CLI user. I kind of like the UI here of VS Code because I can just look through all my code really easily. So I haven't really embraced the CLIs. I did try out the new GitHub Copilot CLI and it did work. But I don't see it as being my primary way of working when I'm in a repo, because I do really like, as soon as like maybe for a small repo, but as soon as a repo has lots and lots of files, I really like having the file explorer here that I can just like look through. But I know many people like the CLI approach. So, great. If you like the CLI approach, you can use the Copilot CLI, you can use other CLIs like from Claude Code, and whatever works for you. I would say the important thing is that is to add something like the agents.md file. It is supported by many agents. It is not yet supported by Claude Code. For Claude Code, you have to do claude.md. So you could do a symlink or a copy there. But agents.md is supported by quite a few agents. So I would really recommend adding an agents.md so that all of the agents you use, all the ones that support agents.md, can be more successful. All right, let's see if there's any other questions. Okay. All right, so I think we've covered a lot of the questions. So please do come to our Python AI series. I also have weekly office hours in the AI Discord. Let's go ahead and share the link for that so that people know about that. Here we go. We'll share that link as well. So there's lots of opportunities to ask more questions. And we'll also share the link for the slides. So if any of you want to reference the slides, you can do that as well. See a couple of last questions. Any information on an official Clippy return? I know everybody wants Clippy coming back. No, I cannot reveal. I don't really know. I think that's beyond my pay grade. I assume like Satya is in charge of that, and he's the only one that can decide if Clippy will return. But I know there's a big fan base for Clippy. I remember when I was a kid. All right. Thank you, everyone. Thanks so much for all the great engagement, all the comments and questions in the chat. Hope this is helpful for you, and hope to see you at future live streams and the office hours. Bye, everyone.
Thank you all for joining, and thanks again to our speakers. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find our survey link on the screen or in the chat, and we'll see you at the next one.